Hello and welcome everybody. This is Noah, and in this video we are going to be graphing trinomials when the leading coefficient is 1. Alright, we're going to look at a couple of examples in this. The instructions, it says, given the following functions, determine the y-intercepts, the y-intercept mirror point, the vertex, the x-intercepts, and 2 additional symmetrical points before graphing the function. Let's give myself a little space between these problems here. We're going to start by finding the y-intercepts. So the function we're going to look at is f of x equals x squared plus 2x minus 8. To find the y-intercept, we are going to plug x equals 0 in, so f of 0 equals negative 8. So the y-intercept is the point 0, negative 8. So to find the y-intercept mirror point, which is the next thing that it asks for, I'm actually going to find the vertex first and then come back to that. So even though the order in the problem says find the y-intercept mirror point next, we're going to find the vertex first. So for the vertex, we're going to use that the x value of the vertex is given by that little formula, negative b over 2a. So in our case, that is going to give us negative 2 over 2 times 1 equals negative 1. And so the y value of the vertex is going to equal f of the x value of the vertex, which we just found to be negative 1. F of negative 1, this equals negative 1 squared plus 2 times negative 1 minus 8. Simplifying this down, we get 1 minus 2 minus 8 equals negative 9. So the vertex is the point negative 1, negative 9. So for me, I like starting to graph at this point. I like getting the y-intercept and the vertex plotted, and that will help me find the other points. So I'm going to give myself some space because there's going to be a little bit of work still to find all the rest of the points. Draw me some axes. The vertex is at negative 1, negative 9. And I also know that since this is a positive leading coefficient, the parabola opens upward. And the reason I'm mentioning this is to think about where I want to put my graph. If the vertex is at negative 1 and negative 9, and it's opening upward, that means I probably want to put the x-axis up higher and have more space down below when graphing this. Now we could have just put it in the middle had we not known that, and that would have been totally fine. We would just at that point kind of have to figure out a scale or make one of the axes longer as we went through this. Let's get a scale on this. We've got negative 4 over here, a positive 4. Let's say this is a 3, and then negative 3, negative 6. I'm realizing I'll put that on the other side. Negative 3, negative 6, and negative 9. And I was thinking that because that point, negative 1, negative 9, is going to go right here, and I don't want to get in its way. So there's our vertex. Let's note the y-intercept is at the point 0, negative 8, so we can plot that as well. And we can start to see here that this is opening upwards by just seeing how these points are arranged. We know from this that the axis of symmetry is going to go through that vertex, right? So if I mirror the y-intercept across, we'll get this point over here, and I can see that this is the point negative 2, negative 8. I'll list that over here. And from this, we can start to see that, yes, indeed, as I was mentioning before, that this parabola opens upward. So I've started to draw it in here, but we definitely want some more detail. So to add our detail, we want to find the x-intercepts. Give myself a little more space here. So to find the x-intercepts, I'm going to set 0 for y. And I've got 0 equals x squared plus 2x minus 8. And we want to factor this. So x, use some space, times another set of parentheses, x. In the first position, we'll take that negative 8. I want to find two numbers that add to positive 2 and multiply to be negative 4, or negative 8. So negative 2 and a positive 4 would add to a positive 2 and multiply to be a negative 8. So we can get x minus 2 times x plus 4 as our factored form. And from this, we can see that x minus 2 equals 0, or x plus 4 equals 0. So x equals 2, or x equals negative 4. And our x-intercepts are the points 2, 0, and negative 4, 0. So I'll go ahead and plot those. Got negative 4, 0 over here, and then the point 2, 0 over here. So I've got those plotted, and then I want to add a little more detail, and it also specifically says to find 2 additional symmetrical points when graphing. So I think around, if I make a table of values here, got x and y that we're looking for. We've got an x value, the vertex x value of negative 1. I'm going to put that right in kind of the middle here. And then I'm going to think, okay, if I was going forwards and backwards, I'd have negative 2 and then a 0 on the other side of it, a negative 3 and then a positive 1, and then a negative 4 and a positive 2. So that negative 1 had a y value of negative 9. This was the vertex here. And everything around this is symmetrical. If we have negative 2, we get negative 8. If we have a 0, we get a negative 8. For when x was negative 4, we got 0 out. When x was positive 2, we got 0 out. So everything is symmetrical around that vertex. So I think another two numbers that would be nice to have is the negative 3 and the positive 1 to fill in some detail in here. If I try f of positive 1, it's a positive number, so it'll be a little bit easier to work with. We'll get 1 squared plus 2 times 1 minus 8. And this will be 1 plus 2 minus 8 equals 3 minus 8 is negative 5. So we'll get negative 5 for y there, and it should be the same for negative 3. So I'll plot the points, negative 3, negative 5, and 1, negative 5. And it's nice because it looks like those fit our pattern nicely here. And we can draw our nice parabola through all of these points that we've drawn. I'll go ahead and label my parabola, y equals f of x. I've got a scale, I've labeled my x-intercepts, I've also labeled all my key points except the vertex, so let's get that in there, negative 1, negative 9. And that looks good. All right, so there's our first example of this. We just have to go through that process of finding all of those points. It's nice to organize that information in a table somewhere along the way. We need to know how to find all those points. We need the vertex, the x-intercepts, the y-intercept, see that its mirror is across the axis of symmetry, and then find two other points that are symmetrical around that vertex. Let's do one more. For our second example, we have capital G of x equals x squared plus 9x plus 20. Let's go ahead and start with the let's start with the vertex. We'll get the y-intercept after that. For the vertex, we'll start with the x value of the vertex is going to be negative b over 2a. In this case, that's going to be negative 9 over 2. It's not the nicest number, is it? Let's find the y value of the vertex. That's going to be capital G of negative 9/2. Fractions are numbers, and we need to be able to work with them as well as any others. So, yeah, they're a bit of a pain in the butt, but let's not focus on that. Let's just go ahead and plug it in and do the work. So negative 9/2 quantity squared plus 9 times negative 9/2, and then plus 20. Go ahead and simplify this down. We'll have 81 over 4 minus 81 over 2 plus 20. Then I'm going to get a common denominator, 81 over 4 minus 162 over 4, where I multiplied top and bottom by 2. And then the 20 is over a 1, so if I multiply top and bottom by 4, we'll get plus 80 over 4. Adding these numerators up, we get negative 1/4. Take a second there. 81 minus 162 is negative 81. Plus 80 is a minus 1. So our vertex then, I'm going to put this in a table now. X, y, 1, 2. Let's put that negative 9/2, negative 1/4. Let's say this is our vertex. Now we're going to look for the y-intercept. It's going to be, we're going to say, what's g of 0? What happens if x is 0? Oops. G of 0 equals 20. So we'll have the point 0, 20. Left a little space in there. Let's go ahead and plot this, see if we can find the mirror point for it. I don't think I need to do that for more. Let's go here. Actually, no, negative 9/2 is the vertex. That's like negative 4.5. So yeah, we're going to be pretty far left for most of this graph, it looks like. Push this right. The vertex is just below the x-axis. So I'm going to put my x-axis down a little lower. The y-intercept is 0, 20. So this is 10, and this is 20. Then my y-intercept is here. And then negative 9/2, negative 4.5 is going to be, let's see, there's negative 3, and then negative 6, so negative 4.5, and then negative 1/4. These are going by 2's here. This is negative 4. Negative 1/4 is pretty close to that x-axis as that looks. And we can see that this is upward facing. It's going to have to go up from that vertex to hit that y-intercept. I'll label this point negative 9/2, comma negative 1/4. Oops. Negative 1/4. Now we want to go ahead and say the axis of symmetry is right here at x equals negative 4 1/2. So that means if we go over to negative 9, and go up to 20, we'll get the mirror of the y-intercept. All right. So I'll label that negative 9, 20 on my table. And let's see. All right, the x-intercepts are going to probably not be the greatest numbers, but I'm not exactly sure. Let's take a look. Myself a little more space here. There we go. So for the x-intercepts, I set y equal to 0. I say 0 equals x squared plus 9x plus 20. And then we'll factor 0 equals x times another x. We want two sets of parentheses multiplied, x in the first position of each. I want two numbers that multiply to be 20 and add to be 9. We have 1 and 20, 2 and 10. That doesn't seem to work. 3 doesn't go in. 4 and 5 multiply to be 20, and those also add to be 9. There we go. We want a plus 4 and a plus 5. This is nice. All right, so if we solve this out, we'll get x plus 4 equals 0, or x plus 5 equals 0. So x equals negative 4, or x equals negative 5. So our x-intercepts are the points negative 4, 0, and negative 5, 0. So I'll go ahead and put those in the table. We've got negative 5, 0, negative 4, 0. And we can plot those. Now those aren't helping us with a whole lot of detail. They're so close to that vertex, right? So let's plug in a couple more numbers. I feel like I want something in these spaces, you know? So I think I want to have like a negative 2 in there somewhere. So if this is going to be out of order. Let's move this negative 9 and the 20 up a little. And what was that? The 0, 20. That's right. Move the 0, 20 down. Let's do negative 2. And that's halfway between negative 4 and 0. And a negative 7 here would be symmetrical about that vertex. So I'm looking for what is the point that's at the negative 7 and negative 2 locations. So if I say G, capital G, of negative 2, this equals negative 2 squared plus 9 times negative 2 plus 20. So that's a 4 minus 18 plus 20. And that'll add up to 6. So those should both output a 6. We'll get negative 2, 6 is here. Negative 7, 6 is here. And that gives us a bit more information, the ability to draw a little bit nicer curve. So we'll connect our dots in a nice parabola like U shape here. Label my points. I've got negative 4, 0. And we've got negative 5, 0. We've got negative 7, 6. And we've got negative 2, 6 over here. Put arrows on my parabola. Label it y equals g of x. All right, if we want to summarize this, we say I'm finding that vertex first, set up a table as you go. And that table is really just to organize the information that we're finding. We want to find the y-intercept and its mirror. So we'll say that's 2a and 2b. And this goes with, we want to graph, start graphing right in here. Oops. Start graphing at this point to help find that mirror. So we can find those x-intercepts. And then once we have that, step 4 is look at the graph to decide what other points you want. And there's no right or wrong answer there. And maybe there's a wrong answer. I wouldn't want the points where x is like -1,000,000 or whatever. I probably don't want to use a fraction there. I just want to look for some nice whole number x values that are within the picture that we've drawn that can add some detail to it. So once you've decided that, then go ahead and plug that x value in, find its mirror point, and then connect the dots and all of that, and you've got your graph. All right, everyone. Thanks so much for watching. Go ahead and try the Now You Try problems that follow. And in the next video, we'll walk through the solutions to that.